In this portion of Module 10, we're going to explore the systems development lifecycle. If you've never heard of the systems development lifecycle, you may be wondering what it is. It's defined as tracing the history, otherwise known as the life cycle, of an information system. It's also known as the traditional methodology used to develop, maintain, and replace information systems. So, this is a structured process which allows you to go through the process of implementing different information technology and systems in an organized and repeatable fashion. While the acronym SDLC is used frequently, there are actually many different SDLC methodologies. They all generally include a variation of a set number of phases, which include analysis, design, implementation, maintenance, and evaluation. But it's important to be aware when you're looking at SDLC not to be alarmed if you find examples of SDLC with steps that have different names or components than the standard ones. One thing you will start to see here is that, like some of the other life cycles or processes we've seen earlier in the course, some of these phases look very familiar. So, a lot of life cycles follow this analysis, design, implementation, maintenance kind of cycle. Let's start off by taking a look at what generally happens in typical SDLC phases. In the planning phase, you have a general overview of both the company or organization and the objectives that you're trying to reach by going through this systems development process. You should have initial assessments of information flow and your requirements developed. You investigate the technical aspects of hardware and software requirements. You should assess what the system costs will be. So this is the cost to bring in or develop the system, as well as the operational costs, which will be your costs on an ongoing basis to maintain and run the system. In the analysis phase, you're going to first look at any problems that were defined during planning. So any areas that looked like they were an issue, you're going to take a closer look at them to see if you can find ways you're going to handle those or resolve those. You should also audit user requirements. So one of the areas that's very important to develop requirements is from the user, as they're the people who will be using that system hands-on on a day-to-day basis. If you go and develop your system without consulting your users, you're probably going to have a system that does not meet the needs. You also need to study existing hardware and software systems. You need to know what is in place, your as is, so you can develop what your to be will be. So this is similar to when we did workflow analysis, looking at your as is and to be. You'll also, in this stage, create logical designs of your systems, particularly if you're looking at software systems. For your information, you'll build conceptual data models, and you'll look at what your inputs, processes, and outputs are to the software or system you're developing. You then do a detailed systems design. So this is where you will design the actual processes of the system. Here, your technical specifications are developed. So earlier on, you looked at user and business type of requirements, and here's where you go a level down and look at your technical requirements and specifications. You lay out any steps that are needed to convert from old to new systems. So a lot of times you will have data in place, and when you move to either a new software application or to a new piece of hardware, you need to take into account how do we get our data from that old system into the new system. And that can actually be one of the longest and most involved steps of doing systems development. Also in this step, you start to plan out your training principles and methodologies. You need to be aware when you do these kinds of activities that you will frequently have a number of different training sessions that will need to be done at various levels. So everything from a higher management level, uh, giving an overview of what the new system or technology is, um, down to the actual user level who will work with system hands-on and need to understand the more detailed information about how that system works and how they will work with it. In the implementation phase, you install the hardware, database management system, and application programs. So depending on the system you are developing, you may have one, two, or all of these different areas. You also will do a cycle of coding, testing, and debugging if you are doing application programs, either development from scratch or installing existing or purchased applications. You may, if you're doing DBMS, customize the system by creating tables and views that are specific to what you're doing. And you should develop user authorizations and permissions. Security is a key area, and during the implementation phase, you will develop those authorizations and permissions. And the final main phase is maintenance. So this is what is done on an ongoing basis. And there are a few different types of maintenance that are done. The first is corrective maintenance. So this is when you have your system in place and you find that there are system errors or bugs in the system. These need to be corrected. So this is where you will do the corrective maintenance. Adoptive maintenance is due to changes in the business environment. So you've put, in this case, a new system in place, and then over time there is a change to the business. This change isn't significant enough to have you put a whole new system in, but it may call for you to make some changes to the system. And then the final type of maintenance is called perfective maintenance. And this is maintenance that's used to enhance the system. So this is to add a totally new feature to the system to make it better for the users. The difference between adoptive and perfective is that adoptive changes existing parts of the program in relation to the business environment, while perfective does add-ons or enhancements. Chima bases their version of SDLC on the Witten, Bentley, and Dittman model of SDLC, which was published in 1997. So as you can see, there are more than the 5 phases we originally looked at. However, they do contain those phases plus some additional ones. And you can see that this is done as a circular model because in systems development life cycles, it is an ongoing cycle that you keep moving through and repeating the steps of over and over again. You'll notice that each of these different areas are color-coded. As we move through and talk to them each in detail, you can align the colors to make it easier for you to determine where we are in the cycle. So in Chima's version of SDLC, um, we start with preliminary analysis. We're saying start in this case, but really because it's a cyclical model, you could start anywhere in the model. But first step, preliminary analysis. Then you do a more detailed system analysis and a requirements definition step. Once you have your analysis of your existing system and your requirements, you can move on to systems design. So this is looking at what your 2B is going to look like. You can then move into development. So this is where you do the actual work of developing the software or system. And from there, you do integration and testing. So integration is where you look at what you have to do to make this integrate or talk to other systems or databases or organizations. And testing is where you look at doing tests at various levels, which we will talk about in more detail, to ensure that what you have developed meets what you have documented as being your requirements. Once you've successfully done your testing, you can move forward into acceptance. This is where you get buy-off from your stakeholders that what you have developed is what they expected. Your installation step, where you physically or electronically install the hardware and software, and the deployment, which is when you put that installed software into production. And we'll talk a little bit more about the differences between installation and deployment. Once it's out there being used, you then move into the maintenance phase. The maintenance phase is the longest phase because this is where you're working in an operational mode, and you only do maintenance when you have one of those three different types of maintenance comes up. When you have a bug or a system error, when you have to make changes due to business requirements, or when there's been a request to enhance it. And for maintenance, if you determine that there is something that needs to change, this is where you'll move into preliminary analysis again and continue on with the cycle. The first step we'll look at in detail is preliminary analysis. In preliminary analysis, you're going to identify what your need is. So this is the problem or opportunity that brought you to the point where you know you need to make changes or implement something new, and you move into the systems development lifecycle. Preliminary analysis, you should make sure that your need is linked to the organization's strategic direction. So this is something you've seen when developing your business cases. You definitely want to have a linkage there in order that you're going to get buy-in from management. And you're going to document the scope of the problem that you're going to try to solve, or the process you're going to try to improve by doing this software development or technology solution. You identify what your alternative solutions are. Again, this is something you've seen with business case. And frequently you do interviews with key stakeholders to get some high-level input as to what they would be looking at with respect to what their needs requirements are. These will get refined as you move through the requirements development, but getting some input from the key stakeholders at the outset will help you to ensure that you're on the right track. And you also want to start, even at this early stage, gaining user buy-in. It's a mistake to wait towards the end of a SDLC event to include the users, because you will miss gathering their needs, as well as if you spring something on them at the last minute, you're much more likely to encounter resistance rather than acceptance of the new system. So starting off gaining user buy-in early on is a way to help ensure the success of what you're working on. In the systems analysis and requirements definition phase, you're going to break down the goals of the project you're doing into defined functions and operations. This makes it easier to work with them and to ensure that the tasks that are required in order to achieve them are all completed. If a system or process already exists, you're going to evaluate the current functionality of that system or process. And you need to look at not only what that one does, but also how the new or upgraded functionality is going to fit in with what does exist today. And this stage is where you also, in requirements definition, begin building your in-depth requirements, and you move beyond working from your key stakeholders to a wider stakeholder base to increase the scope of what you're looking at for the requirements definition. At this point, we're going to take a little bit more in-depth look at requirements development, and distinguish what the different types of requirements you will gather for each SDLC or project you do. These types of requirements will also be ones you need to look at for your assignment 3 in your request for proposal when you have to document some requirements in order to give to the vendors. So as you can see from the diagram, there are a number of different types of requirements. There's functional technical, non-functional, use case, and business. You'll see that to the outside of the circle, I've listed a couple for each different type of requirement. So you will see that they're all uniquely numbered. And a convention in a lot of organizations is to begin the requirement with an acronym that indicates what type of requirement is. So for example, for business requirements, it's BR for business requirement. The functional technical is FR for functional requirement, NF for non-functional, and UC for use case. This means that when you're talking about these later on, if you're talking about them out of context, it's easy to tell which section they fit into. You'll notice that they each have a unique number, and it can be within a section. So you may have business requirement 1, business requirement 2, business requirement 3. In some cases, they will continue the numbering when they move into a new section. So have functional requirement 3 because the last business requirement was 2. However, this is hard to keep organized if you do it this way, because if later on you add a new business requirement, the next business requirement could then be, potentially business requirement 5. So it becomes confusing and you start to wonder if you've missed documenting some. So a better way to do it is to start each of the different types of requirements with the number 1 and continue on as you add requirements. So you'll have a business requirement 1, a use case 1, a non-functional 1, and a functional 1. So let's look at the definitions. Business requirements is where you should start. These are the high-level requirements that management or board of directors would typically understand. So the ones I've put here are very high level, and they're maybe not quite as professional as you might document in your organization, but it's to kind of give you an idea of the sorts of things you would look at. So in this case, we have an example. Business requirement 1, we need a new EHR system. So this is something that management or the board of directors would understand. It's also something that's at a level that could tie easily into your strategic plan. Business requirement 2, the EHR should link with other hospital systems. So here they're talking about interoperability to other hospital systems. Again, it's at a very high level as opposed to getting down to a technical level as to how you would do that. The next type of requirement are technical or functional requirements. So these are very detailed requirements, and they outline exactly what needs to be delivered. And typically, these ones are aimed at the business analysts, developers, project managers, and testers, so those kinds of levels. And the technical functional requirements describes what a system should do. So let's look at a couple examples here. So our functional requirement 3, health card number will be used as the unique patient identifier. So that's, very concrete. It's telling you exactly what you need to use for a certain field within your system. Functional requirement 4, data from the EHR system will be loaded to the data warehouse every night at midnight. Again, something very concrete that says what the system should be doing. Some other examples of functional requirements And keep in mind, these are just a few examples. This is by no means an exhaustive list, but it'll give you an idea of a few things. Legal or regulatory requirements that must be met. Historical data, so existing data, what you're going to do with it in terms of, maintaining it, bringing it into the new system, etc. What the reporting requirements are. And this could be reporting in a number of different ways, whether that's an actual printed out report or reporting into a database or other system. And reporting could be internal within your own organization, or it could be external to an organization such as CIHI. What external interfaces you need to have. Again, this is where you might have to interface into CIHI or Ministry of Health. Things like what audit tracking will be required and done, what the authorization levels will be for the system, and how people authenticate when they log into the system. It can include things like administrative functions and also information on what happens when information is entered into the system, and then subsequently if there is corrections that need to be done or adjustments. This is especially important in areas such as EHR, where there is a need to maintain information that is put into the system even when a correction is made, so that you can see that change just like you would within a paper record. Non-functional requirements are requirements that are not included in the functional requirements, and they generally relate to either quality characteristics or attributes of the system. So a way to think about these ones is they describe how a system works or behaves as opposed to what it should do. So for example, non-functional requirement 1 relates to availability. And in this case, they have the EHR system must maintain a 99.99% uptime. Non-functional requirement 2, performance. The response time on entering an update must be under 1 second. So you can see that one of the differences between the non-functional and the functional requirements is that non-functional requirements tend to be ones that you can very easily put into terms of measuring something. So they will have like an uptime percentage or response time or some type of measure as to how well that system is working or how it is behaving or performing. So that's one way to help distinguish between functional and non-functional. Some additional examples of non-functional type of requirements include things like scalability, so how much you can expand the system in the future. Capacity, this can be in terms of memory or how much storage space you have, etc. Availability, which measures how much the system is available to the end users. And it takes out things like maintenance windows or sets up information around how much of an outage you can have before it becomes an issue. Reliability, recoverability, so how quickly you can recover your system if it goes down. Things like security, or data integrity. So there are a number of these different aspects that are very measurable that fall under your non-functional requirements. The last area of requirements development that we'll look at is use cases. Use cases are generally more complex to document than the other types of requirements and tend to be often used more with systems development that is more software environments or software application development. Use cases are stories that detail the different uses of the system. So similar to in our workflow process, when we talked about actors, generally you consider the actors involved when you do use cases. And these use cases should tell a story of what function the system does for you. So let's take a look at two use case examples we have here. Use case one would be to log into the system. So in step one, you start the EHR application. Step two, you click on login. And you can see this is very specific. It's telling exactly what the actor or the person involved would be doing at each step along the way. Step three, enter username and password. And then step four gives an indication of what the system will be doing at that time. So you are redirected to the main menu. Use case two is entering or changing some information. In step one, you're going to enter the patient demographic screen. So as a user or an actor, you go into that screen of the EHR. Step two, you click the edit button. Step three, you click on the field that requires an update. Step four, you enter the revised information, and it says step four again. It should say step five, you click on save. So you can see that these tell little stories as to how the system gets used. When you do develop these, often they have a graphical representation of what you're doing as well as the steps documented in this manner. Let's take a look at what a requirement might actually look like when it's documented. Now, keep in mind, this is just one way of documenting requirements. This is an example from the format I used to use where I worked, but it'll give you an idea of how a well laid out document for documenting your requirements looks. And this will span over 4 slides because I've broken it up so it's a little more readable. So you can see that it starts off and it's got the unique number BR003, and you can tell from BR that we're looking at a business requirement. And the requirement is given a title, Manage Ongoing Inventory. In the boxes below, it gives the requirement ID and the requirement type, which we've already talked about. And if there was a use case that was associated to this requirement, it would be documented here. But in this case, it's not applicable. Next is a description of the requirement. So this is to provide a mechanism to manage the new telecom inventory and functions of ordering and billing management for the new telecom environment. To complete a one-time physical inventory of phones and directory numbers and create a process that will keep the inventory up to date on a daily basis as changes occur. So you can see that there are a number of components to this that all go into what is required to manage the ongoing inventory. When you look at functional and non-functional requirements following this, it would break these down into greater detail. This one has the rationale. So this is why the stakeholders at a high level have said they need to have this requirement. So the rationale is that the phone inventory has to remain current and accurate for moves, adds, and changes. This source is John Smith, so this is documenting exactly the stakeholder that this came from. And if there's a document associated with it, that's also marked. So in this case, this was identified as early as the charter for this work. Then has acceptance or fit criteria. So this is what you're looking to have as your end deliverable, something that you can tangibly tell that yes, we achieved this or no, we didn't. In this case, it's an inventory listing from the telecom environment that is accurate and up to date. We then look at the level. So this one, because of the size of the company, these were documented as to whether they were requirements on a global or local level. And then the priority of the requirement, whether it's an essential one, so these are mandatory requirements, or conditional, so if certain things happen, then we have to have this requirement in place. And that could be something like if a new law was passed by a certain date, you might need something. And then whether it's an optional requirement. So optional ones are nice to haves. By putting priorities on them, it helps you determine if you don't have the budget to cover everything, which ones you're going to include and which ones you may not. Then the status of the requirement, whether it's in draft status, whether all the stakeholders have agreed to it, or whether it was rejected. Because sometimes people will put things in there that they would like as requirements, but it's deemed as something that is not needed. It also has a change history, so you can see that it goes through a progression. The requirement was documented, updated to add clarity, and then updated again during team review. The next example we'll look at is one of a functional requirement. One of the things you'll see right off is that the unique name is significantly longer. The organization at the time did include certain requirements that were standard requirements that, if you were doing a certain type of, for example, software application, you would have to include these certain standard requirements as well as whatever ones you had added for yourself. So the STD-RQS relates to the standard requirements. But the key component here is FN, which is functional. They had FN for functional, and it was 004. And it was titled Failed Transaction Handling. Similar to the last one, you can see it then documents the ID, the requirement type, which in this case was a behavioral requirement, and the version of the requirement. You'll notice that there's a different field here called parent requirement. In this case, there isn't a parent requirement because it's a standard one that gets put in. But the goal with parent requirements is that when you build your functional and non-functional requirements, you link each of them back to a parent requirement, which will be a business requirement. And this allows you to trace through so you can determine that there is a flow through from the higher level business requirements to the more detailed functional requirements. Again, there is a description. So in this case, all batch processing reports that failed are managed in a data store that facilitates retrieval, transfer, and deletion of transaction records. And then it gives some additional information that must be included within that tracking. The rationale behind this was all failed transactions must be tracked to ensure proper disposition, so how they're going to handle these failed transactions. The source, I've just put in Water's Edge Audit Services, and then a source document. It may have come from an assessment that identified there was an issue previously. Acceptance and fit criteria. So the requirement is verified by passing the following test case, and it lists a specific test case. So what this company did was when they set up standard requirements, a lot of the times they would also develop standard test cases with them, which made it significantly easier to put these into place. It was like having building blocks you could work with. Yes, we're going to include this requirement, and here's how we'll design it and implement it, and here's how we'll test it. There's a section for whether there's any dependencies. So if this is dependent on anything, in this case, no. Any tailoring guidelines. So when you do standard requirements like this, a lot of times there will be some leeway for tailoring it if you have to adjust it slightly. So in this case, they had only for applications which require the management of individual failed transactions per the business owner. So in your business requirements, if the business owner for this application you were developing said, we don't care about individual failed transactions, you wouldn't have needed to actually use this standard requirement to its full potential. You just would have had to put it in here to indicate that you had considered it. Similar to the other one, it has areas like whether it's a global or regional one, and that's specific to the type of business it was being implemented for. There's one for the status. So again, this is where you would look at whether it was, you know, just drafted, approved, or been modified. And then any description or justification regarding the status. So for example, if the status had been rejected, why it was rejected. And then an area for the change history, so you can track how this requirement has changed over time. The next example is that of a non-functional requirement. I'm not going to go into as much detail on this one as you've seen most of these sections in the previous example, but you will see things that are common: a unique identifier, a title, whether a parent requirement is included, a description and a rationale for why this requirement should be included. You will see a source, so where the requirement came from, as well as the document that it came from. Then there are acceptance or fit criteria, which is a way of allowing you to verify whether the requirement was adequately incorporated, whether there are any dependencies or tailoring guidelines, what region it falls under, and then the information about the status and any description or justification if needed, and a change history to document how this requirement has evolved over time. The final requirements example is that of a use case. And you can see it has a unique ID, proj.uc.2, and it has a name, Access Shared Area. There's a version number, so you can tell if it's the original version or if there's been changes to it. And then it documents the purpose of the use case: test user access to a shared server. This has who it was last updated, who it was approved by, and on what dates those were done. As well, it indicates what the user or actor is, in this case, a business user. The business owner's name, Sue Smith, is identified, as well as her contact details. And when you look at use cases, usually you start off with a trigger. So what starts this story happening? So in this case, the trigger was the end user attempts to access a resource file from a shared server. References, if there are any specific references you need, you can document them, but in this case, there were none. How often this occurs. In this case, it's a high use. And then any preconditions. So in this case, the user is connected to the intranet network over a wireless LAN. The user must also have to have a valid and active ID on the network in order to be able to do this. And the user has to have been authenticated on the network shared server. And then any post conditions, so any things that happen to have to happen after this story or the use case completes. So the post condition is that the file that exists on the shared area server was successfully opened. There was places to document whether there were any associated non-functional requirements, assumptions, or business rules. In this case, there were none. And then it gives you an idea of what the steps. So this is the interactions between the actors and the system, as well as any, if you have conditional statements, you can express an alternate way that the steps could happen. So I've cut this back so it'll fit onto one page and made this very simple to give you an idea of how one of these might look. So step, login. The user enters his credentials for the login. And then what the system does in response is that the user is authenticated and logged in. So the next step, the user initiates the request to open file. And the user action that does this is the user double clicks on the requested file after navigating to the folder on the shared server. What does the system do in response? It opens the file. So in some cases, you will also have an alternative flow, and this can document a different way the story happens. So in this case, the user attempts to log in, like the first one. The user enters credentials, and the system authenticates them and logs in. Uh, then the next step is to initiate a request to open the file. In this case, the user cannot initiate the request to open the file because the icon isn't present in My Computer or Explorer, or because the user didn't authenticate properly. And then the system action is that it cannot open the file on the shared drive. So if you're thinking about workflow, it's almost like thinking about two different ways you would go through a workflow. If you were thinking of going down a process, it would be the user enters his credential. Is the user authenticated? Yes or no? And here's what happens if the user does authenticate. He opens the requested file after double clicking on it. If he doesn't, here's what happens. So just kind of think of these as little stories. We're not going to use cases really for our assignment, but you should just be aware of what they are and how you build them, just in case you ever get identified as someone who may help to build use cases as somebody who has a role within some of these. We're going to move on from looking at requirements to designing the system. So system design describes the features that are desired in the new system. So this is similar to the 2B you looked at when you did workflow. The design can include both technical or functional and business rules that must be followed. All of these components are important to ensure that the system is going to work as you intend it. You also do confirmation and acceptance of the design. So once you've gone through and designed what you would like your system to look like, you're going to uh, show it to the end users, to the subject matter experts, etc., to get confirmation that what you've designed, they're in agreement that it should fulfill the requirements. And then you get acceptance, which is official approval from your stakeholders that yes, they agree this is what the design will look like. At this point, you may also develop process diagrams, and these can be how data flows through a system, or they can also be process diagrams that relate to workflow and show how you're going to work with this system once it's implemented. You also develop documentation. This is one area that is often overlooked, but if you do not adequately document your system, uh, there are a number of impacts. Your end users will not be able to work effectively with the system. If they run into issues, they will have nowhere to go to find answers potentially. So you want to ensure that there is sufficient documentation that's going to assist the end users in performing their jobs. Additionally, if there is not behind the scenes documentation, particularly when you're developing software applications, it can be very difficult in the future if you have to make changes to the system. So when you develop code for a software application, you should always be putting documentation actually in the code as to what each different segment of it does. As well, you may also have a manual or a document repository about the application that the people who do programming changes or maintenance on the system down the road can refer to in order to ensure that they are still meeting the guidelines and that they're doing work appropriately on the system given its use. Once you've done your system design and it's been approved, you can move into the development phase. So in application development, this is where your actual code is written. The system is documented as well, and in this phase, any training materials are developed. Now, these training materials can be aimed at a management level to give a high level understanding of your system. They may be aimed at your end users, so the people who will use it on a day-to-day basis, and those training materials may be much more detailed. Or training can even be aimed at the people who will ultimately maintain the system so that they have an understanding of what they need to do to keep it up and running. At this stage, you also begin your first type of testing, which is called unit testing. In unit testing, you test individual modules of code. So you break your system down into a number of different modules, and you test each of those modules independently. Further testing will test those modules together to see if they work as a whole. But at this stage, you're just doing the very introductory testing of each section as you write it. The next phase in SDLC is integration and testing. At this stage, you bring all of the pieces together into a testing environment. And these pieces can include software or applications you've developed. It can include hardware. It could include things like network and network capabilities, or it can include things like interfaces to other systems or outside organizations. The goal of this is to check how the system functions. At this point, you want to make sure that all of those acceptance or fit criteria that you documented in your requirements are being met, and that you identify and correct any bugs or errors in the system. As well, at this stage, you want to validate interoperability if you need to have connectivity to other systems or organizations. And then once testing is done, it's important that there's acceptance of test results. So this is where the people who have been identified as approvers of test results take a look at what has occurred and sign off on them saying, yes, we agree that the testing has been successful. As you can see from the diagram, there's a number of different types of testing: unit testing, smoke testing, integration, system, regression, performance and load, and UAT, which is user acceptance testing. We're going to talk in more detail about a number of these just to give you an idea of what these different types are. The main stages of testing are unit component, system, integration, and user acceptance. I mentioned unit or component testing in the development phase. So this is where you've tested the individual components on their own. The next stage is when you do system testing. So this is where you bring all of these individual units you've tested to make sure that the entire system works as a whole and that everything flows the way it's supposed to. Once system testing is successful, you will also do integration testing. This is where you test interfaces to your other systems or your interoperability. And then you do user acceptance testing. So in user acceptance testing, it's a little different in that rather than having people do the testing who are testing experts or who are developers, you will actually use your business users or your end users. And when you do user acceptance testing, you make a copy of production data, so actual data that you use, and you bring that into your test environment for the business users to work with. This allows them to run the system, and knowing what their production data is like, they're able to verify from a business or user perspective that the results they are seeing coming out of the system are what they expect to. User acceptance is a very important aspect because the users have the very in-depth knowledge and understanding of how the system should be working and what the results they expect are. So a lot of times business users will catch things that the developers or test experts may miss because they just don't understand the business data as well. Additionally, business users give you really important feedback on things like usability. So, is a screen set up so that it is efficient for them to use, or is it set up in a way that's going to be awkward or cause them extra work? So, like I say, user acceptance testing, very important area, and one that you'll generally receive some of your best feedback on areas that can be improved. In addition to these standard types of testing, there are other types of testing which can be added in, just depending on what type of system or technology you're trying to implement and what you need to verify. So some of the other types are smoke testing, which is a type of sanity or confidence testing. And this is where you just go through and check through the main functions quickly. Um, to get a very high level view of, overall, does it look like it's working? Regression testing is testing that's done to make sure that older functionality still works as it did before. This is most often used when you're making changes or modifications to an existing system. And the goal of regression testing is to make sure that although you've put new pieces into the system or modified them, that everything else still works like it did, and that your new changes did not cause any existing functionality to break. Performance testing is used to determine how responsive the system is, how quickly it can process things or the throughput, how reliable it is, or if it's scalable under a given workload. Interface testing tests the connectivity and translation of information to outside departments and or organizations. This is where you would look at, if you were in HIM in a hospital, maybe you needed to interface out to the pharmacy department. So that would be one type of interface, or it could be interfacing outside of your organization to somewhere like CIHI. Disaster recovery testing tests the ability of the system to handle disasters or business continuity issues. Disaster recovery is a whole area unto itself, and in the final lecture for this course, we will actually talk about disaster recovery and planning for it and testing for it in a little greater detail. And there's also security and penetration testing. So this tests the security of your system. And this is especially important when you're setting up something that is public facing or internet facing. As soon as you open up systems to people coming in from outside your internal organization, the level of security must be assured so that you don't put any of your health information at risk of exposure. The next phase is acceptance, installation, and deployment. So at this point, final acceptance of the solution is given. This is where the stakeholders look at your results of having developed the system, your test results, whether you're ready to move forward to deploy, etc., and give you a go-ahead to do the install. Training is also conducted during this phase. And then new hardware or software is installed. So this is where you go and put the hardware out to where it needs to be located, or move software from the test environment into your live environment. Then the software or system can be put into production. And then following that, the actual business of the organization begins to run. So it can be a bit confusing, the difference between installation and production, or installation and deployment. Production and deployment are used interchangeably, but installation involves putting the new hardware in place or moving the software code from a test area. So when you install something, the system is in place, but it's not yet being used. When you move it into production or when you deploy it, this is in essence flipping the switch. So this transitions from the software or hardware just sitting there not being used to being actively used and transitioning from whatever old system you were into the new one. And the final stage of SDLC, at least before you cycle around and begin it again, is maintenance. Maintenance occurs on an ongoing basis during the entire life of the software or system. So while the software system is being used, it's continually being evaluated for any issues with how it's running or for any potential changes that are required by the business or that may enhance the functionality. So these changes can also involve just changes to functionality, upgrades, or corrections. It's important to note that maintenance is considered to be the longest stage of SDLC. So, for example, all your other stages of it, may take you, if you were putting together a new system, a matter of a few months. But once that system's in place, it could then be in maintenance mode for the next 5 years. You may come out of maintenance mode for short periods during that cycle to go through and do an upgrade or a correction, but for most of the life of the system, it is going to be in this maintenance mode. So we've completed talking about the systems development life cycle. As I did mention, this type of life cycle is used for many different things, and you've seen some other life cycles earlier in the course. We're going to as well talk briefly about the database life cycle, or DBLC. The database life cycle is a subset of the SDLC, and it has its own version of the life cycle. Many activities in the DBLC are similar to the larger SDLC cycle that we just looked at. While the phases correspond to the SDLC, they have tasks in them that are needed to be followed in order to create databases that are both well designed and effective for handling data. This is an overall view of what the database lifecycle looks like. As you can see, similar to SDLC, it is cyclical in nature. So you start off with a DB initial study. This is where you initially look at what you're going to need for your database, what kind of data will be included in it, what kind of layout you need, etc. Then you will go into a more detailed database design. From there, you go into implementation and loading. Loading is a step that is not typically one of the high-level steps of SDLC, and it refers to loading any required data that you need to start off with in the database into the database. This can be somewhat involved because it can also include pulling information from older databases and moving it forward. Once you've done implementation and loading, you can move on to testing and evaluation. And then you move into operations, so your day-to-day operations where your database is up and running. And from there into maintenance, so you go into the maintenance mode, as well as they call it a step of evolution. So it's understood that over time, databases may change. So there is a pathway ongoing that allows you to evolve the database as the business needs drive it. Let's walk through the different phases of the DBLC. In the DB initial study, you need to analyze the organization. So the objectives, the operations, or how work is done and what data is used, as well as the structure. And from there, you define any of the problems you have that might be addressed through your database development, as well as any constraints you have. You should obtain user input on how and why system failures are occurring within the organization. This will give you an idea of some of the things you may want to improve when you do your design for your database. You should define objectives, and you should be aligning the designer's view of how the database should be set up with the user's expectations of what they expect to be able to do with the data from the database and how they intend to use it. You should also define scope and boundaries. Scope is the extent of the design according to the operational requirements. So this helps define things like data structures and the size of the database. Boundaries are limits that are external to the system, and often these can be imposed by hardware or software. So for example, if you have a limit to the size of your storage, your hard disk, that may be a boundary to your database. In the DB design step, you need to design the database in order to support organizational operations and objectives from the initial study. One of the important things to consider is the minimal data rule. And this states that you want to include all the needed data. So everything that is needed is included. And you also want to make sure that everything you said you needed, you truly do need. So you want to incorporate all of the data that's important to incorporate, but don't over collect data. If you over collect data, it bloats the size of your database, can negatively affect performance, and you end up with data out there that you really don't need and are not using. Also, in the database design phase, you're going to actually determine which database management system you're going to use. So are you going to use an Oracle database or an SQL database? Those kinds of selections. You will also do data model creation, and this is a main component of the design. There's 3 different levels of it. So the top level is the conceptual design, and this is creating a database structure that represents real-world objects. There is a logical design, which translates that conceptual model into tables and views in the database. And then a physical design, which includes your storage structures and access paths for optimal performance. In the implementation and loading phase, data is loaded into the tables. At this time, any required data conversion is completed. So in the case where you are moving data forward from an old legacy system, or where you're bringing data from various other systems to do an initial load of your database, any data conversion that is required to make that happen is completed. Also during this time, you make sure that all needs are met. And these needs include performance of the database system, that the appropriate security is in place, that backup and recovery for the database has been established. So if something goes wrong, if data is corrupted or if there's a disaster event, you're able to get your data back. You want to make sure that there are data integrity checks in place, that organizational standards, such as naming tables and views a certain way, have been adhered to. And if there are any external standards that you need to comply with, such as legislative type standards, those also have been accounted for. Moving into testing and evaluation, the database administrator, or DBA, both tests and fine-tunes the database. Some of the areas that are considered during this phase are performance, integrity, access, and security constraints. In addition, testing of the database against the system evaluation criteria is done to ensure that the database is meeting the documented requirements. In the event of a testing failure, the database administrator must modify the physical or logical design, or upgrade or change the database management system that's going to be used. Once the database passes the evaluation, it can move from that phase into the operation phase. This phase is also the phase from which system evolution can start. It's normal that as a database is in ongoing operation, that unforeseen issues may arise, or that there may be a demand for changes to the system created by business need or outside factors. So operation is your normal day-to-day kind of mode, but keep in mind that you may be pushed out of operation into evolution as changes are required. And the final phase we'll talk about is maintenance and evolution. This is where your ongoing maintenance activities happen. And these can include things like doing backups, doing recovery of data if it gets missed or erased. It can include performance enhancements to the database, as well as assignment and maintenance of access permissions. It includes generation of statistics on the database, security audits, and system usage summaries. This phase also includes evaluation as to whether upgrades are needed and whether modifications or changes need to be done. And if they are identified as needing to be done, then it will lead back into the database initial study phase again, thus completing the cyclical nature of the DBLC, very similar to how the SDLC works. That's the end of this section on SDLC and DBLC. If you check the readings at the end of the slide deck in D2L, you will see there is a section in your textbook which is recommended as reading to go along with this.